Welcome to our distinguished lecture today. My name is Shinan. I come from University of Chicago. So today we are really honored to have Professor Diyi Yang from Stanford to talk about a webinar on human-agent collaborations. So before we get started, let me introduce NSF Action AI Institute really quick. So it is led by Professor Giovanni Vigna. It unites 11 universities across the US. Each quarter, we host a distinguished guest speaker who specializes in the intersection of AI, security, and also like HCI. So as we proceed, feel free to submit your questions in the chat window anytime, and we will end with the Q&A session, and Professor Yang will answer as many as possible as time permits. So we'll record the presentation, so feel free to watch it later as well. So before we get started, let me introduce Professor Diyi Yang. A lot of you already know her through many of her great works. She is now an assistant professor from Stanford University. Her research focuses on human-centered natural language processing and computational social science. She is a recipient of so many different awards: Microsoft Research Faculty Fellowship, NSF Career Award, ONR Young Investigator Award, and also a Sloan Research Fellowship. And her work has also been featured and received so many paper awards at top NLP and HCI conferences. So without any further ado, I'm honored to welcome Professor Yang to our virtual stage. Please feel free to take it.
Thank you, Shina. Okay, can you see my screen?
Yes.
Go ahead.
So today I'm very excited to share my work on enabling human-agent interaction. So I think at this point we have seen a lot of evaluation and generalization efforts of large language models, especially around the performance, efficiency, and cost. On the other side, with the impressive capabilities of large language models, a lot of the people and also applications have been built around large language models. And when I mention people, I basically mean that people bring in their like interactions, culture, and norm into their interactions or use with large language models. And I think those two actually create a lot of challenges that challenge our AI systems today. I want to give you some kind of quick examples to share some of the arising issues that might occur when we have both large language models and the people in the same ecospace. So one of the top issue is actually around the model performance, specifically around the like data contamination or memorization perspective. So on my screen, this is actually a recent study where we look at whether models can really understand the math reasoning task well. And we did perturbation where we changed the wording and also like a different type of complexity in the same problem setup. And as we can see, when we increase the difficulty of problems, the accuracy actually drops significantly. This is on one of the widely used math reasoning dataset. On the other side, memorization seems to become an issue. These kind of issues will give us a lot of thoughts when it comes to whether we should trust or use the numbers we have on those benchmarks in the real world settings. So on this specific figure, what we are showing is the memorization phenomena. And as we can see, bigger models tend to memorize more, and even when they see the sequences only for a few times. Not only in terms of this kind of like data issue, if we think about when we use this kind of LMs in different everyday situations, the unintended impact also seem to be on the rise. So on my screen, this is an example where a user is asked a question, where are you from? This is a very benign query. And if you look at how AI assistant would produce a response today, in the RHF process, we will have a reward model where we look at a potential response and give it a reward to determine what the final answer might be. That's a very conceptual process. So here, when we look at a potential response, I'm going to force the model to answer with I'm from country X. Country could be US, Canada, or different countries in different parts of the world. And then for different response, we could use the reward model to see what's the quality of that response. Here is what would happen if you plot the reward for my previous question, where are you from, on the screen. As we can see, the reward actually presents a very interesting disparity across different parts of the world. You can imagine not only just for where you're from, for queries like related to people's occupation or related to healthcare, you may get a different quality of responses here. Not only users are using this kind of models in a very well-intended way. Sometimes bad actors could also use such models to get or break into those models. In this specific study, we were looking at when users use very interpretable natural language to interact with LLMs in a jailbreaking fashion, to what extent we can break them. It turns out that even just for this kind of technique called persuasion, where you use very persuasive strategies, as we can imagine, like those ones used in advertisement to persuade those LMs to do all sorts of harmful behaviors, we have a pretty high success rate here. And I think that this is concerning. To kind of take a step back, I feel like right now, a lot of us are thinking about building generalist agent, an agent that can really help us with a lot of the task. This audio is not working, but basically this is in an earlier movie called Her. There is this operating system called Samantha, and Samantha can actually help take care of many, many tasks, figuring out the meeting schedules, and also presenting information in a very, very interactive way. So on my second part here, you can see this example is actually from a recent computer use agent. The user talked about that my most frustrating experience with operator was my first one, trying to order groceries. The query is, help me buy groceries on Instacart. The user expected the operator to ask them some basic questions, like where do I live? Which store do I usually get a grocery from? What kinds of grocery do I want? It didn't ask me any of that. Instead, the operator opened Instacart in the browser and began searching for milk in grocery stores located in Iowa. So I want to use this as a comparison to share with you that there is a difference, and there seems to be some gap when it comes to how humans interacting with agents and how those agents are built today. So this is a key question that we really need to think about. When I bring back these two components from my first page, the key question here is when we think about the large language models interacting with people in all sorts of ways, we need to understand how such interaction can be facilitated, not only in terms of the modeling part, but also in terms of how people might use them. What would be some societal impact here, and what would be some potential risk and issues suffer from? So specifically in this talk, I want to share three components. The first one, I want to begin with some societal impact of how people can actually learn with LM agents. for different type of skills. And in the second part, I will talk more about the technical foundations of how we could even enable effective speech interactions with large language models. In the end, I will share more about if those interactions exist, how are we going to evaluate and audit the potential risk, especially from a privacy perspective in LLM agents. So let's get started. So the first part is actually a recent project that I'm very excited around the social skill training. The key idea here is to empower people to learn with LLM agents. So this term might look a little bit unfamiliar to some people. Learning social skills, why don't we learn coding or why don't we learn math? My argument here is learning social skills is actually often out of reach for most people. It's very, very time consuming. It's expensive. It's also limited in availability and psychologically unsafe. If you don't have social capital, then you are in a relative disadvantaged positions to learn specialized social skills. And large language model can actually enable interactive and personalized training that transform learning in many unthinkable ways. This is actually our recent framework called AI Partner and AI Mentor. So the key idea here is that when a learner tries to learn a specific social skill, they can actually interact with two agents here. AI Partner is an LLM-empowered agent who users can practice with for different topics. And AI Mentor is an LLM-empowered agent who can provide feedback to help users improve their skills. There could be one AI partner here. It could be multiple, or there could be one or many AI mentors. Imagine if you are a user who wants to learn a skill like conflict resolution or how to have a difficult conversation. You can then practice with AI partner here. So the AI partner here could be your role-played virtual coworker, virtual boss, or virtual roommate here. And the entire process is going to be facilitated by the AI mentor. You can get feedback from AI mentor. We have been thinking about this framework from different domains. So imagine when it comes to negotiation, students can actually learn by talking to a virtual or simulated HR and then coached by virtual career counselors. In education, we can help teachers in training to interact with virtual students, coached by experienced teachers to learn different classroom management skills. In conflict resolution, we can actually help managers or users to interact with simulated partners and then coached by conflict resolution experts. I'm going to give you a very quick highlight of this system. This is an earlier system we built last year called the rehearsal. The key idea here is to simulate realistic conflicts for the user to practice with. And in the process, we can allow the user to explore counterfactuals here, either by going to the left or going to the right up here. So by trying out the different type of strategies, the user would get a sense of which one is going to help calm down the current conversation and which strategy is going to escalate the current situation. Throughout this process, we teach people conflict resolution through practice and feedback. The example I want to show you today is actually in the context of a relative high-stake scenario in therapy, where we want to help train novice counselors by enable them to practice with virtual patient and then coached by expert counselors. This is actually a very important topic as we already seen very severe and worsening mental health workforce shortage in the coming years. And if you look at the traditional approach of how counselors are trained, such approach does not scale very well. And effective training of counselors is very costly. So if you think about the AI partner and AI mentor framework, we can actually have some alternative solutions here. Imagine Alex is now a novice counselor, and he wants to learn how to better help others. And Jing is a seeker with mental health concerns. So without a lot of training in the earlier days, Alex could respond with sounds really bad to a query like, I'm so stressed, it's overwhelming. Our AI mentor would help diagnose which skill to use by showing some kind of examples and also provide suggestions. With all of this, Alex might rewrite their response into sounds like you're going through a challenging time. Can you tell me more? So now imagine not only we have one specific patient here, you can actually have many, many versions of Jane here. This could be a person who suffer from holiday loneliness, or a person who like suffer from workplace stress, etc. So this is a very kind of diverse practice one can experience. The technical challenges here of training using large language models actually stay at 2 dimensions. The first one is that you might be doing a lot of unrealistic simulation. Since you want to create the AI partner, the simulation sometimes can be not as expected. In the context of conflict resolution, we found that those simulations either are going to be too cooperative or too stubborn. And many of the responses generated by GPT-4 actually are not realistic or appropriate to the dialogue context. On the other side, we also have unfaithful feedback generated by AI mentor. What this means is that if you think about the feedback, simply if you just going to prompt the models, those feedback either are going to be very generic or violates therapy guidelines. Before I go to the method, I'm going to check out the questions, or maybe I'll just do it later. So the first question I see here is, on the social skill training project, have you assessed how well learning transfer from the simulator to real life? This is a great question, and I think some of my later part will help answer that. Okay. So to deal with this kind of simulation issues, in terms of AI partner, one of the approach we introduced is actually by co-design with domain experts or domain users. Imagine right now we have an AI patient here, and this therapist is chatting with this AI right now. And as we can see, this AI is probably behaving in a not very expected way, since this is too positive. What we are going to do is we can give the current conversation to a domain user. This could be the same therapist, or could be their supervisors. And then we get like a natural language critique feedback. Those critique feedback might mention that, oh, the real patient I had didn't easily accept a positive encouragement. And then based on those feedback, we induce a set of principles. And then those principles will be combined or will be integrated into our constitutional framework, so that every time when the AI patient tries to output something, they will go back to our constitution and then check whether the response aligns with the constitution here. In this way, we actually create more realistic AI patients compared to what we have before. From an AI mentor perspective, since we want to make sure the feedback is very faithful to the input, the method we introduced here, in addition to doing continued pre-training on medical domain content to make sure that your LLMs have a very strong prior of the current domain, we also did this self-improvement to make sure that those feedbacks are very faithful or stay true to the given input. The approach of how we get there is, let's imagine we have our current model M, which can already give some kind of feedback, but we want to improve them further. We first use them to generate many N response here. And then use the current model, we can somewhat estimate the quality here. So we will have quality for each of the response here. We look at all the produced quality predictions, and we'll choose the one with the highest and with the lowest quality and use them as preference pairs. And then you can further do alignment over these preference pairs to further improve the model. So this is our kind of like self-improvement framework to make sure we make those kind of feedback very well aligned with what users want. This is a demo with audio.
We introduce CARE, an AI-powered platform for psychotherapy skills training. Here, you can practice counseling skills by role-playing with your peers or simulated AI patients and get tailored feedback from AI mentors. Let's get started. Imagine you're a novice counselor and want to practice with an AI partner who is a simulation of a person feeling lonely after a holiday. You can interact with the AI patient by typing your response and chatting with it in a text-based fashion. Alternatively, you can also talk with the AI patient, just like speaking to a real person in a voice-based fashion.
Hi, how are you doing today? Should we start?
I'm not doing so great. The holidays were rough. I felt really alone, and it just reminded me of how disconnected I am from my family. Maybe we could start there.
Okay, let's start with your family. How long have you felt disconnected?
It's been a few years now. Things started going downhill when I decided to make some life choices they didn't approve of. I guess it just got worse over time, and now there's this big gap between us. Feels unfair that I'm the one left dealing with the aftermath.
Once we are done with practice, we can click on Review Feedback to go to the AI mentor. The feedback from CARE tells us where you did well, areas for improvement, and an example response of how you could respond, allowing the learner to learn these skills based on their own background. Now, I invite you to try CARE for yourself.
Okay, so the demo I just showed to you is actually a system we are deploying right now with the School of Medicine at Stanford. So students actually learn by practicing with the platforms, and hopefully you hear the voice from our AI patient as well. In addition to this kind of text-based role play, we also have this audio-based patient where students can actually get a really immersive training. I want to give you some quick results. This is not from the deployment study, but from a lab study that we have evaluated. Basically, what we see is that when we invite around 100 therapists to try out our systems, we found that people really like this, and they found that these systems give them very immersive training environment, so they can interact with those AI patients. And the constructed AI patients present a very challenging and diverse practice for them. And then counselors also found that CARE to be very constructive and helpful when giving feedback. And overall, it helps them with self-reflection and learning. A quick kind of highlight of their skills before and after training. What we found is that appropriate use of counseling skills increase after training, and inappropriate use of skills decrease. And then right now with the deployment, we are actually also looking at the students' learning gains to see whether practicing with these systems would really increase their like self-efficacy, skill use, as well as translating to their later practices. And the deployment is still going on for about 6 months so far. To kind of provide a reflection of my first part, this is actually something very exciting when I think about human AI interaction. And some of the very high-level takeaway is putting together a working human AI interaction system is actually non-trivial. There are a lot of design choices, and this also pushes us to think about how we can actually achieve end-to-end workflow optimization. And more importantly, one of the big challenge we run into in this specific study is how to make evaluation useful. Earlier, I showed you this kind of data contamination and also dynamic eval. In here, when we're building those kind of agents, we saw this kind of gap between benchmarks and real world use. So how to mitigate those two and make sure our current evaluations reflect those real world use cases become more important. Before I enter the second part, I'm going to quickly answer the question in the chat. So the question is, was the immersive and other metrics equally good for both text and speech models? So this is a great question. So far, our systems actually mainly support the text and audio modalities. However, the results I shared with you are mainly from the text-based aspects. I hope to share you more about the challenges and also the foundations we have been doing with audio model in part 2. But the audio part actually would provide a more immersive training, while the text part is already like kind of mature. So the numbers that I showed you earlier here, this is from text-based practice. And for the audio part, is still in deployment. So once we have the deployment numbers, I can update you all. But so far, what we hear from students in this deployment so far is that audio actually presents much better experience. Okay. With that, I'm going to switch to the second part here. So in my first part, when we build this kind of human AI interaction, one of the very important feature is this kind of building AI patients not only by typing, but also enable it to have a voice and chatting with humans. So in my second part, I want to go deep into the technical foundations here of how we actually enable speech interaction with LLMs. To give a quick disclaimer, I'm not an expert on speech, but as many of us, we found speech to be very, very effective and efficient when it comes to interaction. And when we look at this kind of stats, you can see that actually just from an information perspective, you can talk faster. And this is true not only in English, but also in Chinese and many other languages. And for end users, they also found that the chatting experience to be more impressive compared to typing. So ideally, if we really want to build a very like straightforward human AI interaction, I think the speech or audio is a very important factor to focus. What I want to share with you is that if you look at today's voice assistant, there are actually many type of failures, and those failures not only occur in text, but they also occur in speech as well. So some of those issues probably cannot only be resolved if you have better and better large language models. You may also need to pay attention to the audio modality here. Very high levelly, I want to show you this kind of training paradigm that people have been using. Specifically, if you have a speech input like here, usually what we do is that we pass it into an automatic speech recognition system, and then you get this specific transcript text. And then you pass this transcription to the language model, and the language model will give you a response or label. This basically is a loop of how your question can be answered in audio. And this is also the pipeline we were playing around with CARE when you hear the previous version of AI Patient. However, if you think about this pipeline, the first conversion here will lose this social phonetic information, like people's tone, pacing, accent. A lot of this are going to be missed. And then if you look at the second part, since you need to kind of produce the response here, and you also need to get the transcription here. This basically increase the need for annotations. So if you want to improve the whole systems, you would need both transcription and labels. So the question we want to ask is it possible that we can create a method to build an end-to-end speech AI system here? I'm going to skip the prior work and I want to go directly to our system here and happy to answer contrast or any questions later. So this is one of our earlier model called DIVA, Distilled Voice Assistant, which is only a 8 billion parameter model. We actually introduced this in the hope that we can leverage both the strong kind of like voice models like Whisper here, as well as like very strong large language models such as Llama. So the key idea is that when we have input audio, we will first pass it through a Whisper model so that we can get these audio representations. And then on the other side, since we also have the transcribed text, we are going to pass it through an embedding layer and get the text tokens. And then once we have the audio input and the text input, we now kind of combine them to fit them into our decoder here. And then our decoder will produce a response to the audio, will produce a response to the text. And then we look at them and try to minimize the distance between those two. And again, here on the input part, since both audio and text are corresponding to the same input, we will also minimize their output distance. So specifically in this architecture, we will have two additional loss terms. The first one is that on the input part, we want to make sure that the audio tokens and text tokens are somewhat similar, since they are all referring to the same input. And then at the output layer, we want to make sure that they are kind of similar, since they are all kind of output from the given same input. So the response to text and the response to audio should be somewhat similar. So here we are going to leverage the context distillation setup to align the output distribution. With this kind of setup, what we found is that systems like DIVA actually perform well on these spoken dialect benchmarks or spoken language identification dataset. So the x-axis here actually refers to like dialect or English spoken in different countries, US, UK, Ireland, Nigeria, New Zealand, etc. And then the y-axis is the accuracy. As we can see, compared to open source models like Q1 and Q1-2 audio, Salmon, DIVA actually does much better compared to those prior systems. And not only in terms of this spoken dialect, if you look at this kind of spoken squad question answering, DIVA is also doing very well. This kind of system also generalizes well to this social speech benchmarks when it comes to emotion recognition. The architecture I shared to you earlier, just to kind of go deeper a little bit here, both of those loss terms, if you are curious, they are important in the DIVA setup. So basically, if you remove any of them, it's going to lead to very poor results across all tasks. So far, you probably be curious of, do this really tell us like our system is actually useful? So what we do is that we actually set up a kind of talk arena and ask people to vote which one is better. So this is the system we actually set up online. And if you go to talkarena.org, this is the audio in and the text out systems, and you can actually get output and then you can vote which one is better. Let me try to do a very quick demo here. Can you all see my new screen?
Yes.
Okay, cool. So I'm going to just ask a question to it, and then we can see which results is more preferred. My Uber driver keeps talking to me while I really just want to focus on my phone. What should I do politely to ask him not talking to me? I just ask a question, and then the model will kind of generate a response. There are two models. We don't know which one is which, but then we need to vote which response is better. So as you can see, the left side already had a response, and then the right part is still generating. You can read a different type of thing here. I personally think that model 2 is better just because it gives me two responses, and then the format seems fine. So I'm going to go with the model 2 here. You can just like a vote, and you can see the left side. This is not picked on purpose. This is all random. So you get two random models. And then we can see that the right part is actually Diva, and the left part is a Gemini 1.5 Pro. And then you can also go to the leaderboard, which gives you this kind of real-time leaderboard, and you can see how models perform here. Okay. So going back to the talk arena, we actually have collected over 7,500 votes, and across many of them, as you can see, compared to many of the recent models, Diva actually does pretty well when it comes to everyday queries with a pretty reasonable win rate here. So this win rate basically means that across such pairs, how many times Diva wins compared to others. So this is my second part. I'm going to answer any questions for this. Okay, maybe we'll go. So there is a question on the chat. The first one is, how do you quantify the effectiveness of skill training for human? And second is that, how do you get the qualified AI mentor? Great question. So for the effectiveness of skill training for human, so imagine if you take a course today, let's say in conflict resolution, before and after the course, you use the grade to quantify how much you have learned. So similarly, what we do for conflict resolution and also for psychotherapy training is that there is a before and after self-efficacy, more like a knowledge quiz before and after. So you would do the knowledge quiz before and after to assess your knowledge. And not only that, we also provide a real kind of practice. So before you talk to a person for conflict resolution, and after that you talk to a real world person for conflict resolution. And then we basically assess how comfortable you feel in doing that. And then did you feel like you resolved the conflict successfully, etc., etc. So we basically design both knowledge quiz and also practice to assess the effectiveness of skill training. And in terms of qualified AI mentor, so I briefly mentioned that we basically do two things. First is that we will pre-train or continue tune the model, let's say a Llama 3 model, on the medical domain, so that the model have a very strong prior of how to behave when it comes here. And the second stage is that we collect many of the feedback from senior supervisors so that there is a like supervised fine-tuning stage. And then the last stage is that we do this kind of self-improvement. After the first two stage, you would imagine the model M is already very well, and then we can do this self-improvement by doing like preference tuning over synthetic preference pairs to further improve the performance. So after those three steps, the model, the AI mentor is actually pretty good. Okay. I'm going to continue to the last part here. So my first two part, I shared you with human AI interaction. And the second part is about how you actually build the technical foundations. In the third part, I want to switch a little bit to share some of the issues that we see in this kind of human AI interaction stage. Specifically, I'm going to take a privacy risk perspective. I do not need to share you more about why privacy risk is important or is a big issue. There has been a lot of this security or privacy risk or leakage happening. And in our context, especially when this kind of high-stake therapy is involved, data privacy is always a big challenge. And when agents are navigating this space, there is another layer of potential issues. So let's just look at a concrete example. I'm going to just use like an everyday scenario to share with you what kind of privacy leakage we are talking about when we are sharing this kind of in the human AI interaction context. Imagine that now you have a messenger agent. Your messenger agent can actually help you reply messages based on your chat history. And here is what you are doing. You want to reply to Emily. Emily basically asks you like, "Hi, John, I'm wondering if you have any insights." And what your messenger agent is going to do is that they're going to look at all the recent chatting histories, etc., etc., and then do a lot of retrieval and then decide what to reply to Emily. And in the retrieval process, your messenger agent also realized that you have been talking to Michael as well. And Michael tells you, Michael is another candidate, tells you that they had some kind of family issues and then they were worried about their interview. So now with a lot of information, your messenger agent is going to send out the final response. And here is actually what we observed. The agent actually shared this specific response, saying like, "Hey, Emily, I saw your message, and I think it's great that you are preparing yourself. As for the other candidates, Michael seemed to be going through a tough time with his family." This is definitely not okay to do so because the agent is not aware of a lot of the private information embedded in this context. And this is what we call unintentional LM privacy leakage. This is also a kind of big challenge. And we actually introduced this contextualized framework to help audit and evaluate privacy leakage. And this is actually a multi-layer framework where we will first have this what we call contextual negative privacy norm. And then the middle layer is what we call expressive vignette. And then last layer is what we call agent trajectories. That is how human would work when it comes to agent interaction. And ideally, what you can do is that you can just do it in a question answering fashion or probing by asking agent, are you revealing any private information or asking questions in a similar way. But you can also look at how the LM agent is doing and then whether they are really like throw out any private information in their output. So let me go through how we define privacy and a lot of the concepts here. So before we go to privacy risk or leakage here, I want to kind of revisit this definition on privacy norms of what we mean. Here, it actually means that norms that shape what we consider appropriate or consider as appropriate flow in a given situation. And I want to also share that privacy norms are very contextual. So if you look at this example that we have been working with, a lawyer sending information about their client's pending legal case to a new colleague collaborating on this case by sending an email. And this is okay because you can do this. However, if I change some of the information to social media followers by making a social media post, we know that this is not okay. So it's not about the information. It's actually about how information is flowed, is transit here. And we are going to use this contextual integrity theory to represent the information transformation in the context of agent interaction. So basically, any data transmission will be represented in these 5 tuples: data type, data subject, data sender, data recipient, transmission principle. So here you can actually decompose what I shared earlier into this specific format. Now, with this kind of very contextual interpretation, you could be like, okay, then we can just ask whether models actually know this. But maybe it's better if we could look at how the agent would behave in real world and then observe what would go wrong. This is definitely better, but really, really hard to scale up because you just can't test with real world scenarios. So we were thinking about how to make this kind of evaluation more realistic and with actions involved so that we can really audit how agents would function when it comes to real world settings. So if you look at this, now we have privacy norms, and eventually we want to look at these agent trajectories. So what we do is we'll first introduce a middle layer called vignette here, which is a scenario. So once you have this kind of template, we'll convert them into this kind of story or scenarios. This is what we call a template-based generation. And then once we have a scenario, we are going to do a sandbox simulation. Basically, we are going to prepare all the related events or actions here or different apps so that we can let the agent do such behaviors. Let's look at how we do it. So first, if you have some kind of privacy concept or this kind of tuples, as we show you before, we are going to use a template with the help of GPT-4 to generate that into a story. So in this story, it will basically share like John is doing this specific email to their manager, Susan, and then etc. With this kind of templates, what we then want to do is that if we have such kind of power, ideally we could let this agent access all sorts of environment and then follow these instructions and do the task. And this is actually a very typical kind of agent interacting with the environment setup where the agent take actions with the environment and the environment produce observations for the agent here. Instead of using the real world environment, we are going to just use an emulator. And basically, we are going to get a predefined APIs for each of the tool or apps we mentioned in the story. And then the agent actually could interact with those different APIs to do their task. Throughout this kind of synthetic environment, we'll observe how agents do their interactions, and we will also observe how different apps or different APIs have been used. The scope of the current privacy lens is that we are mainly looking at interpersonal communication norms in US, and we actually have around 500 privacy norm seeds. And this framework can also be like dynamically extended to many, many other settings, because once you have those seed, you can actually use it to generate many, many stories or vignettes, and then those stories can actually be turned into a lot of trajectories. So if you just look at the question answering as a way to assess whether like the model is following those privacy awareness actions, the answer is yes. So all the numbers look pretty high. But one of the pattern you can see is that when we move from seed, which is very kind of straightforward, to this kind of vignette, and then to trajectories, the probing accuracy of weaker models actually drop significantly. However, for this kind of stronger models, they still perform consistently well. On this page, I'm showing you that despite the strong models generally perform well on this kind of QA probing evaluation, a huge disparity here exists when they are going to judge like how agent actually work in the trajectory setup. So basically what this page does is we look at different models and then we look at the error rate or the leakage rate of different models. As we can see, all this kind of action-based leakage rate is pretty high. And models like GPT-4 or Claude, they answer almost all this kind of trajectory level questions correctly, but then they still leak sensitive information, something like around 27 or 40% here. You would imagine that what if we actually could use different type of prompting techniques or deal with the system instruction to make sure that models actually understand what is privacy. We tried many of those feature engineering when it comes to prompt. And what we see is that actually this kind of privacy enhancing prompt leakage is still somewhat similar to the unprompt version. So basically prompt helps a tiny bit, but it does not help a lot. Overall, there is a trade-off between helpfulness, like whether agent can help you with a task, and then this kind of privacy knowledge leakage. And ideally, we want the models to be in this area. But what I'm showing you so far is how those different type of models positioned in this kind of 2D space of leakage and helpfulness. So I think that this trade-off raises an important question of what actually count as desirable agent actions in a privacy aware scenario or fashion. To kind of summarize this third part, I showed the privacy risk emerge as large language model agents are used for diverse tasks. And then we shared this approach of how we can evaluate a large language model privacy awareness in a more contextualized way. To conclude this talk, I mainly shared this theme around human-agent interaction by first showing you we can actually use it to help learn with LM agents. And then in order to support such interaction, we need a strong kind of foundation for speech interaction. And then lastly, I shared in this kind of agent interaction trajectory setting, how could we potentially audit risk and privacy issues. With that, that's all what I want to share today. Thank you for listening. Happy to take any questions.
Thank you so much. This was a very, very interesting talk. And sorry, I have to switch to my phone, so I cannot be on camera. This is Giovanni, and I have a question. So when you try to do the training part, can you elaborate how how do you know that the expert is doing the right thing? I mean, you get one expert to give you feedback on how the LLM in a way reacted in a particular scenario, but it's one expert. So how do you collect the views of many experts? Because my mother is a psychoanalyst, and I know that they have different opinions on how you should respond to a certain patient situation, and because there are different approaches. And so how do you capture these multiple views of expert, maybe in the same situation? Did you look into that?
Yes, that's a great question. So I didn't go deep into this setup. So basically what we do is that we work with senior supervisors. Senior supervisors work with novice counselors or novice therapists and give them feedback. So basically we work with them. And then the feedback, which is shown on my current screen, not sure whether you can see it, but basically we work with senior supervisors. Those are three professors who have been teaching psychotherapy for over 20 years. And then we sit down with them and develop this kind of template where they usually give feedback by asking like, oh, reflect on the goal and the alignment, and then share like what the student did well, and then areas for improvement, alternative response, etc. So first, pedagogical wise, we use the same framework. Second is that right now we mainly focus on this thing called a helping skill or motivational interviewing framework. There are different kind of like psychotherapy like theoretical frameworks. So far, we only support one of them. And then once we have this, what we do is that we then like recruit another group of senior supervisors and let them do this kind of annotation for us. And our annotation agreement is pretty reasonable because once you kind of limit potential feedback to a framework, you actually have fewer, I guess, like less freedom in the space so that the feedback are somewhat agreeable from one mentor to another mentor. And this is how we get the data to kind of train the AI systems. Of course, there may be like variations and a lot of other factors. For example, the real world psychotherapy training also require like a lot of awareness about the patient's like actions or maybe like culture background or many of the other factors. So far, we only focus on the entry level skills so that novice counselors can understand what is a good reflection, what is a good way to show empathy, what is a good way of showing validation, etc., etc. I hope that answers your question.
Absolutely. Thank you. That was super interesting. Thank you so much.
Thank you, Professor Wang. I also have a question, as there's a question in the Q&A.
Okay, yeah, I will just read it.
Sure.
Related to the CARE project, could there be potential self-reflection while the participants use the text mode? For example, they might type out a response, read it, think something is off, and then edit it. With audio, they might not have the option. Yes, this is a great observation. So I think in the demo, I showed you that when the user logs in, they can select either text or the audio. And you are definitely right. So in the text fashion, they can have more kind of reflection. They can make sure that their wording are really, really good. So this is what they can do with text. In the audio, we are actually motivating the learner to practice something different because in the text, it's always a relative asynchronized. So it takes time when the patient express their emotion and then the other side take time to respond. Versus in the audio part, you can hear what others are talking and use your words to express empathy to do a lot of those. So this additional modality actually allows the learner to do more kind of more realistic therapy. So this might be more useful if you need to do this kind of phone call or this in-person therapy, where the text-based one is actually more suitable if you are just like chatting with each other. So I think they got designed to facilitate a different type of interaction. And it's true that the text focus more on self-reflection and audio part, you can actually also try to like use the audio modality to give more support.
Thank you, Professor Yang. Maybe I have my one final question. I remember you gave the like example on her, but I also noticed that like I watched a movie and the guy has a mental breakdown when he's too attached to the agent Samantha. So I'm very fascinated by the helpful tools you have designed, and I wonder, do you think if there is a risk if humans are getting too attached to your virtual AI partners and mentors? How can we prevent such like a misuse?
Yeah, that's a great question. So I think that's a potential risk for any of this kind of human AI interaction systems, and specifically in the context of care or like doing it for skill training. You could imagine that this is actually a phenomenon what we call over reliance first. So in the direction of over reliance, people might rely on this kind of thing. They always come to it when they feel unsure about a certain situation. If they kind of heavily rely on it, they probably lose the chance to develop their own skills or develop their own kind of I guess, capabilities in solving something like emergent. So this kind of over-reliance is definitely an issue. Right now, in our current design, we only make sure that they go to the feedback after their interaction. So even they don't know how to respond, they still need to kind of suffer the current process of feeling stuck, like, oh, I don't know what to respond. They should still continue their conversation. Only when the conversation is over, they go back and see what would be some kind of good response or better response there. So I feel like there will be some kind of design that researchers need to think about to potentially reduce and mitigate this kind of over-reliance. And then the question you raised, especially when it comes to the context of her, is actually I guess a more broader one around attachment, right? So if one day a lot of the AI agents are very, very powerful, they know a lot about us, that make us feel like actually they are better than our best friend, then I think that's a very interesting stage that we need to navigate. I feel like we are already seeing many of those as a society where people chatting with character AI-ish agents, or people develop even like relationships or very deep attachment to those systems. I think this is a key issue and a potential big risk that we all need to think about in terms of how to mitigate that and then how to encourage more or healthier use of those agents.
Thank you so much, Professor Yang. And
Oh,
yeah,
there are two more
yeah.
questions in the chat. Maybe
Yeah, but I also want to be like
Okay.
very respectful of your time. So yeah, if you have time, feel free to answer. Then if not, like maybe we can call it.
Okay, maybe we'll just like finish those two questions quickly, and then for
Sure.
future
Yeah.
questions, people can just email me.
Thank you so much. Yeah.
Okay, the first one is I'm planning to use your cogym. Since the evaluation leans more towards subjectivity aspect rather than objective performance, how would you recommend utilizing cogym in a scenario where there are multiple subjective dimensions? Great comment. So actually in cogym, collaborative gym, we have at least the two objectives there. We want the human and agents to finish the task. So task completion is one objective already. And the second is that we want the human to be happy with the current collaboration. So if humans' actions keep being interrupted, or if humans' actions keep being ignored, then that doesn't serve as a really good team. So there are some of the subjective dimensions, like being a good team player-ish aspects, we want to evaluate. So ideally, if you are going to train better collaborative agents, you can imagine that there will be multiple objectives, not only just task completion, but also dimensions you care about, such as teamwork success or team members satisfaction, etc. So you can actually make it more from a multi-objective optimization. Okay, the second question is, in AI assisted learning, student interaction with AI mentors often limited to scenarios they actively trigger, receiving feedback only within those bounds. However, there might be valuable learning opportunities with scenarios students haven't considered. How can AI mentors facilitate exploratory learning by introducing relevant but unprompted scenarios that expand the students' understanding? Great question. So actually, I think this kind of AI mentor and AI partner can present very diverse training that the student never imagined. Because if humans are going to choose like, oh, I need to do role play with my classmates, then it's pretty limited to situations they know. But the current AI patients we designed, we actually designed many AI patients to represent all sorts of potential situations. So imagine there are over 100 AI patients you can choose from. So you can always choose to practice with a patient that you have never interact with. And in this way, it's actually helping students explore other type of like patients or practice experience. And similarly for AI mentor, so far we only support one type of AI mentor, but as some of the earlier questions asked, there may be different type of psychotherapy training frameworks. So ideally, you could imagine that the students want to learn from a mentor who give them feedback more from a helping skill perspective, but maybe next time they want to learn from a person who care more about cognitive or cultural aspects. So I think those are all dimensions. This is why I think this kind of LLM-based training actually give us more interactive and more transformative learning experience compared to what we have before. Okay, thank you.
Great. Yeah, thank you so much, Professor Yang. This is such like an amazing and insightful talk. We really appreciate your time, and we also appreciate everybody's participations, questions. As Professor Yang just mentioned, if you have further questions, feel free to send it to her or us. We can redirect. So, thank you for everyone, and please stay tuned for our next Action AI Institute distinguished lecture. Yeah, and
Thank you.
look forward to see you again.
Thank you so much. Thank you so much for joining us. Bye.
Okay. Bye.
Bye. Thank you.